Dear students, today let us have a look at some more problems on differentiation. Let's have a look at this question. Question number 147. If step x denotes the greatest integer contained in x, then for x between 4 and 5, what is the derivative of step x? As we know, step x, when x lies between 4 and 5, step x is defined as 4. So I can write like this: step x is equal to 4 if x is greater than 4 but less than 5. Hence, dy dx of step x is equal to dy dx of 4. Derivative of 4 is equal to 0 because 4 is a constant. Third option. 149 question. If f of x is an odd differentiable function defined on minus infinity to infinity such that f dash of 3 is equal to 2, then f dash of minus 3 is equal. So I will come back to this question afterwards. First we shall look at the next question. Okay. First I will solve this 150th question, then after that I will come back to 149. Let f of x be an odd function, then f dash of x is. Okay. Students, do you know what are odd functions and even functions? I will briefly explain what is an odd function and what is an even function, and after that I will solve this problem. Okay. Even function means a function f of x is said to be an even function. A function f of x is said to be an even function if f of minus x is equal to f of x. If f of minus x is equal to f of x, then we say that f of x is an even function. For example, f of x is equal to x square. So here, what is f of minus x? F of minus x is equal to minus x whole square, which is same as x square. So we observe that f of minus x is same as f of x. Therefore, x square is an example for even function. Then you look at cos x. Cos x is another example for an even function because cos of minus x will give you cos x itself. So if I treat this as f of x is equal to cos x, f of minus x is equal to cos of minus x, that is same as cos x. So this is also an even function. Then if I consider sine square x, f of x equal to sine square x, f of minus x will be equal to sine of minus x whole square. Sine square x is nothing but sine x whole square, right? So sine of minus x is minus sine x, but minus sine x whole square will be plus sine square x. So this is also same as f of x. Hence, sine square x is another example for an even function. Okay. So then, f of x is equal to 3x power 4 minus 2 into x square plus 7. This is also an even function because you check that f of minus x is equal to 3 into minus x whole power 4 minus 2 into minus x whole square plus 7. Minus x whole power 4 is equal to x power 4 itself. So you get 3x power 4 minus x whole square is x square, which means minus 2x square plus 7. This is f of minus x, which is equal to f of x. F of minus x is equal to f of x. Hence, f of x is an even function. Is it clear now? What is an even function? Now I will explain what is an odd function. A function f of x is said to be an odd function if f of minus x is equal to, we say f of x is an odd function if f of minus x is equal to minus f of x. If f of minus x is equal to minus f of x, then we say that f of x is an odd function. For example, sin x. Sin x is an odd function since f of minus x will be equal to sin of minus x. Sin of minus x is nothing but minus sin x. So I can write this as minus f of x. As we can observe here, f of minus x is equal to minus f of x. So this is an example for odd function. Then x cube plus 2x. This is also an odd function. You observe here, if I call this as f of x, f of minus x is equal to minus x whole cube plus 2 into minus x. So minus x cube minus 2x. Take minus as common, minus of x cube plus 2x So this will give you minus f of x. F of minus x equal to minus f of x. This is another example for an odd function. Okay, is it clear now what is an odd function and what is an even function? Now if I consider, so you remember this, f of minus x equal to f of x, that means it is an even function, and if f of minus x equal to minus f of x, then f of x is called an odd function. Further, look at this example. F of x is equal to 2x power 4 minus 3x square plus 3x plus 6. This function is neither an odd function nor an even function, because you observe here f of minus x, 2 into minus x whole power 4 minus 3 into minus x whole square plus 3 into minus x plus 6. Minus x whole power 4 is x power 4 only. Minus x whole square is x square, so minus 3x square is equal to minus 3x plus 6. This is not same as f of x, because here you have plus 3x and here you have minus 3x, and certainly not equal to minus f of x either. So this is neither an odd function nor an even function. So you should not come into a conclusion that every function whatever that exists in this world should be either odd function or even function. Not necessary. There are functions which are neither odd nor even. This is an example for a function which is neither odd nor even. Okay. So now here the question is, if f of x is an odd function, then what happens to f dash of x? Okay. So for this, let me take some examples of odd function I will take. So I will take, when I say odd function, I can think of sin x, x cube plus x, 2x power 5 plus 6x cube minus 4x. These are few examples for odd functions. Now if I differentiate them, what happens? Let us see. Okay, this is f of x. I call this as f of x. Then f dash of x, derivative of sin x is cos x. If this is f of x, then f dash of x, derivative of this is 3x square plus 1. If this is f of x, then our f dash of x is 10x power 4 plus 18x square minus 4. Okay? Now you observe this cos x, what kind of function it is? Cos x is an even function. 3x square plus 1 is an even function. 10x power 4 plus 18x square minus 4, this is also an even function. So from this we observe that the derivative of an odd function is an even function. Then what about the derivative of an even function? Derivative of an even function will give us an odd function. You just check it. If I find again its derivative, so I am finding f double dash of x. Derivative of cos x is minus sin x. Here the derivative of 3x square plus 1 is 6x. Here the derivative of this is 40x cube plus 36x. Observe all this f double dash of x, all three cases, these are all odd functions. So from this what we observe is that the derivative of an odd function is an even function and the derivative of an even function is an odd function. Okay. Now look at this question. Let f of x be an odd function, then f dash of x is. So f of x is an odd function means f dash must be an even function. Okay, which is the first option. Okay, now let's go back to the previous question, which is 149th question. If f of x is an odd differentiable function defined on minus infinity to infinity, such that f dash of 3 is equal to 2, then what is f dash of minus 3 dash? So f of x is an odd function that f of x is odd. Okay. If f of x is odd, what happens to f dash of x? We already know that if f of x is an odd function, then f dash of x is even. This is an even function, right? F dash of x is an even function. So if f dash of x is even, then I can write that f dash of minus x is equal to f dash of x. Because you just recall the definition of an even function. Definition of even function. A function f of x is said to be even if f of minus x is equal to f of x. Now f dash is an even function. If f dash is even, then we can write f dash of minus x is equal to f dash of x. F dash of minus x is equal to f dash of x. Now we want to f dash of minus 3, put x equal to 3 here. We get f dash of minus 3 is equal to f dash of 3. F dash of 3 value they have given, that's equal to 2. So if f dash of 3 is 2, f dash of minus 3 is also equal to 2. 2, which is the third option. Okay. Just by looking at 2, don't click the second option as the answer. Answer is the third option. Okay. Then 151. The function f of x is equal to mod x minus 3 if x is greater than or equal to 1, and it is x square by 4 minus 3x by 2 plus 13 by 4 if x is less than 1. It is not continuous at 1, not derivable. Derivable is another word for differentiable. Not derivable at x equal to 1. Continuous and derivable at x equal to 1. Continuous at 1 but not derivable at 1. So we need to test the continuity and differentiability of this function at x equal to 1. Okay. Let us say how this function is defined. F of x is equal to x square by 4, I'll write that first, x less than 1, x square by 4 minus 3x by 2 plus 13 by 4 whenever x is less than 1. And it is mod x minus 3 when x is greater than or equal to 1. Okay. Here, mod x minus 3, how do we define mod x minus? Mod x minus 3 is equal to x minus 3 if x is greater than or equal to 3, and 3 minus x if x is less than. Mod x minus 3 is equal to x minus 3 if x is greater than or equal to 3, and 3 minus x if x is less than 3. This is a well-known fact. Already we have seen such functions on quite a few occasions, right? So, mod x minus 3 is equal to x minus 3 if x is greater than or equal to 3, and 3 minus x if x is less than. Here what they have defined, mod x minus 3. This function is defined as mod x minus 3 whenever x is greater than or equal to 1. When I say greater than or equal to 1, it may be less than 3 or it may be greater than 3 also. So I will split this into two cases now. That is 1 to 3 and then 3 to infinity. So further I can write like this. This function f of x is equal to, here I will written as it is, x square by 4 minus 3x by 2 plus 13 by 4 if x is less than 1. And here greater than 1 is there? No, 1 to 3 I will consider. 1 to 3. 1 to 3 means it is less than 3 only. There it is defined as 3 minus x. 3 minus x if x is greater than or equal to 1 but less than 3. And after 3, that means when x is greater than 3, greater than or equal to 3, it is defined as x minus 3. Okay, did you understand? See, in the given function they have defined the f of x as mod x minus 3 whenever x greater than or equal to 1. When x greater than or equal to 1, that means I am talking about 1 to infinity, right? So the function is defined like this. Minus infinity to 1, it is defined like this, and 1 to infinity it is defined as mod x minus 3. So this I have, in this interval I have retained that f of x as it is, and this interval 1 to infinity is there now. I have split this as 1 to 3 and then 3 to infinity, that's all. 1 to 3 it is defined as mod x minus 3, there since x is less than 3, mod x minus 3 will be equal to 3 minus x, and when x greater than or equal to 3, mod x minus 3 will be equal to x minus 3. Okay. So now let us start the solution. We want to test the continuity. First I will test the continuity at x equal to 1. Say to the left side of 1, the function is defined like this. To the right side of 1, function is defined like this. So there we will find out left hand limit and right hand limit. Left hand limit to the left side of 1. When x is less than 1, put x equal to 1 here. We get 1 by 4 minus 3 by 2 plus 13 by 4. That's equal to 1 plus 13. 14 by 4. 14 by 4 I will write as 7 by 2. Minus 3 by 2. 7 by 2 minus 3 by 2 is 4 by 2, which is equal to 2. Left hand limit is 2. What about right hand? Right hand limit, put x equal to 1. 3 minus 2. Left hand limit is 2. Right hand limit is 2. So the function is continuous at x equal to 1. Now we have to go for left hand derivative and right hand derivative. Left hand derivative, differentiate this and put x equal to 1. When I differentiate 2x by 4, that means x by 2 minus 3 by 2. At x equal to 1, put x equal to 1, what do you get? 1 by 2 minus 3 by 2, which is equal to 1 by 2 minus 3 by 2. That's equal to minus 2 by 2, which is minus 1. Left hand derivative is minus. Right hand derivative, differentiate this. If I differentiate it, I am getting minus 1. So left hand derivative is minus 1, right hand derivative is minus 1. Therefore, the function is differentiable at x equal to 1. Right? So that means it is continuous as well as differentiable. Continuous and derivable at x equal to 1, which is the third option. Okay, right. Then 153. If f of x is mod x, then what is f dash of 0? So for this, the answer is obvious. I have said this on many occasions that mod x is not differentiable. This is very important. Mod x is not differentiable at x equal to 0. So if f of x is mod x, then f dash of 0 does not exist. Obvious answer. 154. If f of x equal to cos of x square minus 2 step x, f of x equal to cos of x square minus 2 step x, then what is f dash of root pi by 2? They given that x is greater than 0 or less than 1. When x is greater than 0 less than 1, what happens to step x? When x is greater than 0 less than 1. Okay, let's have a look at the graph of step x. This is the graph of step x, right? From 0, 1, 2, 3, 4, 5, etc. From 0 to 1, step x is 0. From 1 to 2, it is 1. From 2 to 3, it is 2. From 3 to 4, it is 3, etc. In that way. So from 0 to 1, step x value from 0 to 1, when x is between 0 and 1, step x will be equal to 0. So this problem reduces to f of x is equal to cos x square. Now differentiate this minus sin x square into 2x. So f dash of root pi by 2, put x equal to root pi by 2 minus sin x is root pi by 2 whole square. That means you get pi by 4 into 2 into root pi by 2. 2 gets cancelled. Sin pi by 4 is 1 by root 2. So minus 1 by root 2 into root pi. That can be written as minus of root pi by 2 minus of root of pi by 2, which is the first option. Then 155. If y is equal to sin square x divided by 1 plus cot x plus cos square x by 1 plus tan x, then y dash of x is equal. So we need to differentiate this one. Before I differentiate it, let us further simplify. Let us see whether we can further simplify. Sin square x divided by 1 plus cot x plus cos square x divided by 1 plus tan x. Okay, that's equal. Sin square x divided by 1 plus this cot x is there now. I'll write cot x as cos x by sin x. Similarly, here tan x I will write it as sin x by cos x. That's equal to, take LCM here, sin x is the LCM. This will become sin x plus cos x by sin x. So this sin x will go up. So you will have sin cube x by sin x plus cos x. Plus, here cos x will be the LCM. So numerator is cos x plus sin x by cos x. This cos x will go up. So you have cos cube x divided by cos x plus sin x. Here we have the same denominator. So y is equal to sin cube x plus cos cube x divided by sin x plus cos x. So numerator is of the form a cube plus b cube. A cube plus b cube is nothing but a plus b into a square minus ab plus b square. That a plus b is sin x plus cos x, so that gets cancelled. So then you have a square minus ab plus b square. Then the sin square x plus cos square x is 1. And this here I will multiply and divide by 2. Sin square x plus cos square x I am writing it as 1. Sin x cos x I am multiplying and dividing by 2. So then 2 sin x cos x I can write as sin 2x. So this is our y. We want y dash differential. Derivative 1 is 0 minus 1 by 2 into derivative sin 2x is cos 2x 8 to 2. 2 gets cancelled. So the answer is minus cos 2x. Minus cos 2x, which is the second option. 156. Let f dash of 1 is equal to 2 and f of 1 is equal to 4. Then the derivative of log of f of e power x at the point x is equal to 0 is given that f dash of 1 is equal to 2, f of 1 is equal to 4, then we are asked to find the derivative of log f of x to the log f of e power x at x equal to 0. I will call this function as y. Let y is equal to log f of e power x. Let y equal to log f of e power x. We want to find out the derivative of this. That means we need to find out y dash at x equal to 0. Y dash, let me differentiate this. Y dash is equal to 1 by derivative of log f of derivative of log x is 1 by x. So the derivative of log f of e power x is 1 by f of e power x into f dash of e power x into now the derivative of e power x, which is e power x. We want the derivative at x equal to 0. Put x equal to 0. If I put x as 0, e power 0, that is 1 by f of 1 into f dash of e power 0, which is 1 into e power 0, that is 1. F of 1 is 4, f dash of 1 is 2. So we get 2 divided by 4, that's equal to 1 by 2. Do we have this option? Yes, we have. Fourth option, 1 by 2 is the answer. 159 question. F of x equal to x when x less than 1 and 3 minus x when x is greater than or equal to 1 less than or equal to 3. Then what is f dash of 1? See, even though you are asked to find out f dash of 1, you need to start with the continuity. You just check whether it is continuous or not, because if it is not continuous, then it cannot be differentiable. Okay, to test the continuity, what to do? For left hand limit, put x equal to 1 here. For right hand limit, put x equal to 1 here. So left hand limit is equal to 1. Right hand limit is equal to 3 minus 1, that is 2. Left hand limit is 1, right hand limit is 2. Function is not continuous. If the function is not continuous, then it cannot be differentiable. So f dash of 1 does not exist. Fourth option is the right answer. 160. F of x is equal to mod of x minus 1 plus mod of x minus 3. Then the question is, what is f dash of 2? Okay. See, let us see how these two functions are defined. Mod x minus 1. It is defined as x minus 1 if x is greater than or equal to 1 and 1 minus x if x is less than 1. Then mod x minus 3, that's equal to x minus 3 if x is greater than or equal to 3 and 3 minus x if x is less than 3. Okay. We are asked to find out f dash of 2. In the neighborhood of 2, what happens? See here, this is 0, 1, 2, 3, 4, etc. This we are talking about the neighborhood of 2. So neighborhood of 2 means this small interval, small open interval containing that point 2. Here, how this mod x minus 1 and how this mod x minus 3 is defined in the neighborhood of 2, that is what we have to consider now. So f of x equal to mod x minus 1. You know the definition of mod x minus 1. Mod x minus 1 is equal to x minus 1 whenever x is greater than or equal to 1, and it is 1 minus x whenever x is less than 1. Okay. So we are talking about the neighborhood of 2. There clearly x is greater than 1. So x lies in this interval. So there x is greater than 1. X is greater than 1 means mod x minus 1 is defined as x minus 1 plus. Now look at mod x minus 3, how it is defined. Mod x minus 3 is equal to x minus 3 if x is greater than or equal to 3, and it is 3 minus x if x is less than 3. Here in the neighborhood of 2, x is less than 3. If x is less than 3, mod x minus 3 is defined as 3 minus x. So x gets cancelled, so we get f of x is equal to 2. F of x is 2, therefore f dash of x is equal to 0. Okay, that's the answer. Third option. 162. If y is equal to log of 1 plus x by 1 minus x whole power 1 by 4 minus 1 by 2 tan inverse x, then dy by dx. Y equal to log 1 plus x by 1 minus x whole power 1 by 4 minus 1 by 2 tan inverse x. Then what is dy by dx? Okay. Let me simplify this. This is of the form log m power n. Log m power n can be written as n log n. So this will become 1 by 4 log 1 plus x by 1 minus x. After that log 1 plus x by 1 minus x, we can write it as log 1 plus x minus log 1 minus x. So on simplification, this will give you 1 by 4 log 1 plus x. See, this is not differentiation. I have not differentiated so far. I am just using one of the properties of logarithms. 1 by 4 log 1 plus x minus 1 by 4 log 1 minus x minus 1 by 2 tan inverse x. Now differentiate this. Y dash is 1 by 4 into derivative of log 1 plus x is 1 by 1 plus x minus the derivative of log 1 minus x is 1 by 1 minus x into minus 1 minus 1 by 2 into derivative of tan inverse x is 1 by 1 plus x. But we need to simplify, right? Because none of the options contain this. Okay. So we will take LCM here. I take 1 by 4 as common. Okay. Then take LCM. Or wait. Yeah, I'll take LCM here. LCM would be 1 plus x into 1 minus x into 1 plus x square. 1 plus x into 1 minus x is 1 minus x square. 1 minus x square into 1 plus x square. That will be 1 minus x power 4. 1 minus x power 4 is the LCM. So here what do we get? Here we get 1 minus x into 1 plus x square. Minus into minus will become plus. This 4 already I have taken out. So here you will have 1 plus x into 1 plus x square. Minus. Here 2 also, because I have taken 1 by 4 out. So another 2 will come to the numerator. 2 into 1 minus x into 1 plus x. So that is 1 minus x square. Okay. That's equal to y dash is equal to 1 by 4 into denominator is 1 minus x power 4. Numerator you just multiply. We get 1 plus x square minus x cube, and here we get 1 plus x square plus x cube minus 1 minus x into 1 plus x is 1 minus x square minus 2 into 1 minus x square, that is minus 2 plus 2x. See whether you can cancel it. Okay, you just observe whether you can cancel anything. Minus x minus plus x is cancelled. Minus x cube plus x cube is cancelled. Then 1 plus 1 is 2, that minus 2 is cancelled. We are left with x square plus x square plus 2x square. X square plus x square is 2x square. 2x square plus 2x square, that will give you 2x square plus 2x square is 4x square. So 4x square by 4 into 1 minus x power 4. 4 gets cancelled. We will have x square by 1 minus x power 4. Y dash is x square by 1 minus x power 4, which is the second option. Okay, then 163. If f of x is a polynomial in x, then the second derivative of f of e power x at x equal to 1. Second derivative of f of e power x at x equal to 1. I call that as y. That y is equal to f of e power x. We have to find out its second derivative. That means y double dash we have to find out at x equal to 1. Y dash differentiate once, we get f dash of e power x into the derivative of e power x, which is e power x. Okay, this is y dash. We want the second derivative. So again we differentiate y double dash. I'll use product rule here. First function will remain as it is. Into the derivative of the second derivative of e power x, that is e power x, plus second function which is e power x, into the derivative of the first derivative of f dash of e power x is f double dash of e power x into the derivative of e power x, which is e power x. Okay, now we want the second derivative at which point? At x equal to 1. Put x equal to 1 here. We get f dash of e power 1, that is e, into e, plus e power 1 into e power 1, that is e square, into f double dash of e. I am putting x as 1. You can take e as common. So if I take e as common, then we will have f dash of e plus here one of those e will remain, e into f double dash of e. So e into f dash of e plus e f double dash of e. That's the answer. So first option being e f double dash of e plus f dash of e. That's not the answer because e is missing. Second option is not the answer. Third is not the answer. Fourth, is it true? F double dash of e into e plus f dash of e into e. Yes. Fourth option is the correct answer. Okay. So with this I will put an end to today's class. We will continue tomorrow.